Hey everyone, what's going on? I'm Jeff Noble, and this is episode 4. The subject for this episode is arrays. There's a couple of times in this course where we're going to talk about some things that are kind of new subjects, and people tend to get lost. I know that when I first learned about arrays, I was not completely comfortable with them, and it really took me a while before I was able to really grasp them. I don't know why. It's not a particularly hard concept, but for me, it did take a little bit. So I don't want you to feel like, and I don't think you will either, but don't be too hard on yourself if it all makes sense, but then when you actually go to put your hands on a keyboard and practice it, that you're a little fuzzy on what to do. It's all about practice. It's all about repetition. I know that you can get it. We're learning C# in 20 minutes. This is the Noble Cause Software Development course. All right, let's jump right into this presentation. We are talking about arrays today. So what is an array? An array is a list of things, like the items in your shopping cart, a list of users in an application, the list of people that are in a chat room, recipes in a recipe box, people in a dating app. All of this data needs to be stored in an array or a list of some type that resembles an array. We'll learn about how arrays are created and how you use them, and then later on we'll jump into some of the more object-oriented versions of arrays that are a little more flexible. In this episode, we're going to be talking about a shopping cart as an example. I think a shopping cart is something that we've all used and that we all understand, so it's a good point of reference. All right, and now it's story time. So when I lived in South Florida, there was this store called BrandsMart. They sold refrigerators and ovens and computers and televisions and cameras and video equipment, and it was just a store that I could go crazy in. So the way it worked was you'd walk up to a sales guy and you'd tell him, I want to buy a TV and I want to buy a surge protector and I want to buy an HDMI cable. And he would say, oh, you got to have the gold cable. I don't know why you have to have the gold cable, but you had to have the gold cable. I think the reason you had to have the gold cable is because that's where they made all their money, because it certainly wasn't on the TV. They had excellent deals. So anyway, he would take this all down and put it in a computer, which would assign an ID to an invoice, right? A number. He would write this number on a little scrap of paper that he would tear off of another piece of paper. He would hand you this little scrap of paper and say, go to the cashier. So you go to the cashier, you hand her the little scrap of paper. She pulls up the order in her computer and she says, okay, you bought all this stuff. Give me all of your money. So you pay her all of your money and she hands you another piece of paper. This is the loading dock piece of paper. And she'd say, pull your car around to the loading dock in the back, hand this to the guy at the loading dock, and they'll give you all your merchandise. So you go out to your car and you pull it around back to the loading dock, and you give this piece of paper to the loading dock guy. He looks at it and says, holy cow, you got a big-ass TV. So he tells one of the other guys, hey, go pull this TV for this guy. He tells another guy to go get your cable, and he tells another guy to go get your power strip. This guy doesn't actually do anything. I guess it's good to be the king. In the meantime, the guy comes back with the gold cable, and the guy looks at you like, you better not drop this because I'm about to throw it at you. And he tosses it to you, and of course, me being a programmer and not an athlete, I drop it. He gives me a look like, what good are you? And I look at my package, which is now slightly scuffed from the ground, and I'm not that happy either. But before I can make any noise about it, he's already throwing the surge protector at me. This time I'm a little more wise, so I duck, and it hits the lady next to me who's looking at me like, hey, what happened to chivalry? And I'm like, I'm sorry, but he already scuffed one of my things, and I'm not taking this one to the head. So I pick up my power strip from the floor, and I put him in my car. At this point, the Incredible Hulk comes out from the back with this TV on his shoulder like it's weighing nothing. He throws it into my car, at which point I'm pretty sure I hear the thing break, and he looks at me and says, don't worry about anything. This thing's got a warranty. So I go home and I live happily ever after with my TV. Why did I tell you this story? Because this story is full of arrays. There are arrays that list all of my items in their computer. There is an item number that they type in and it creates an invoice so that I can pay. That invoice is made up of line items from a billing system that's loaded into an array. The list that prints out that I give to the guy in the loading dock, he's going to look at that, pull that up on his side, and he's going to see an array of lists of things that I need that he checks off one at a time as delivered. So these things are used every day in all systems, and I hope you enjoyed the story, but now we're going to get into the details of how it actually works. All right, so here's my shopping cart. In the shopping cart, it's got my big-ass TV, my gold HDMI cable that I greatly overpaid for, and the surge protector outlet that's going to stop my new investment from blowing up, if it even works, after Gargantuan Man shoved it in the back of my car. So, how does this look to a computer? Well, to C#, we would write string array, that's what the square brackets mean, that there's going to be more than one. Think of those like an empty bucket. We give it a variable name, which is shopping cart. Shopping cart is just like an int or a string or a bool, like we've learned already. But this shopping cart is an array of strings, so it'll hold many strings. How many strings? That's what this 3 is in between the brackets on the other side of the equal sign. This shopping cart variable can hold 3 strings. We need the new operator when we use a string array to tell C# that we needed to create some memory in the computer and a place to store these 3 strings since there's more than one. So breaking this down, string is a data type. The brackets says that it holds a list of that data type. The list can only hold strings. Don't try to put numbers in it unless they're in quotes. The new keyword creates space in memory to hold the array. And 3 is the maximum number of elements that this array can hold. So this will create our empty list that we can put things in, or our shopping cart. And we've named the variable shopping cart because that makes more sense. So what's it going to look like? We're going to put TV in quotes into our string array. Then we're going to put the word cable, and then we're going to put the word power strip. They sit in element 0, 1, and 2 of the array. That makes 3 elements, 1, 2, 3, and that's what this number denotes. If you try to put a 4th thing into this array, it's going to blow up when you run it because we've only made a box big enough to hold 3 things. So when you create an array this way, you have to already know how many items are going to be in that array. Notice that the array starts at index 0 because computers usually count by 0. Just like we saw when we did string format, that the arguments that we passed to our string format were element 0, 1, and 2. Same thing here if there are 3. So how do we actually make TV sit in index 0, cable sit in the next spot, and power strip sit in the next spot? Well, it looks like this. Shopping cart 0 is going to hold a TV. Shopping cart 1 is going to hold a cable, and shopping cart 2 is going to hold a power strip. The 0, 1, and 2 denote the index that we're talking about. So we can actually write it this way, and then we can assign our values into that spot in the array variable. So I'm going to shrink this down for a minute, and we can see that we take TV, and we assign it to shopping cart 0. This should look really familiar to you because it's the same way we assign a value to a variable. Just in this case, we're also going to give it the slot in the array, or the index in the array, that we want that string to live at. So TV now lives at 0, just like we show in this graphic. Same thing with cable goes in slot 1, power strip goes in slot 2. Make sense? I think so. So let's go a little further with that. So we create our new string array shopping cart. We give it 3 elements that it can hold. We set element 0 to TV, 1 to cable, 2 to power strip. Arrays come with some built-in properties that'll help you out, like length. Length will tell you how many items are in your shopping cart. Unlike the 0 index of the actual array, where the first item goes in slot 0, length gives you the real countable number of items in there. So shopping cart.length actually equals 3. Which is what we put in the top here. Even though our array only goes to index 2, it still actually has 3 elements in there because we started counting at 0, but shopping cart.length will actually return 3 because there's 3 items in that array. I'm using interpolation with the console write line here with the $sign before the quote. We learned that in a previous episode. Card. Here we're saying items in cart, and it'll print out 3, which is the length of our current shopping cart array. If we want to print out specific items in our shopping cart, we can refer to them by index and just print out shopping cart 0, shopping cart 1, shopping cart 2. Here I have 3. That is an error. Oops. And it would throw an exception when we run the program. So don't do that. Do as I say, not as I make mistakes. All right, so here is where you can get lost. I've added 4 new lines of code. I've made a new variable called myTV that equals 0, which makes myTV an int since 0 is a number, and the default data type for numbers when you use var is an int. So myTV equals 0, and myoutlet equals 2. So we can see that the TV is in index 0 and the power strip is in index 2. So I hope you see where we're going here. While in these lines of code, I actually wrote the numbers 0, 1, and supposed to be 2. Ignore that 3. You can't see it now. I'm sure if you look the other way, it's not even there. If you notice, I've replaced the numbers with the variable. So now my shopping cart, my TV, for an index, which equals 0, will still print out the same thing that this line that says shopping cart 0 prints out. Same thing with my outlet. We can replace my outlet in the shopping cart array, and it would print out power strip. So I know that's a little confusing at first. It seems to make a lot more sense when there are numbers in there, but as soon as you put a variable to them, it looks a little foreign to the brain. But just know that when you're dealing with arrays, the number in the index is still a number. It just may not be a hard-coded number. It may be a number that lives in some other variable, or could even be a value in some other array. So let's show some of this in practical examples and see how it all works. I'm not going to go through this slowly. If you need help creating a new project, see the card above. So new project, console application, episode 4. Noble cause .arrays, and hit next. .NET 5 is good. Okay, here's our familiar console app. So I'm going to get rid of the hello world line. Okay, let's start off with the basics. We're going to make an int array. I'm going to call it something like numbers, and we will make a new int array, and it'll hold 2 items in the array. So now I can type numbers 0 and assign it to some number. We'll just pick 10. And numbers 1 will just equal 20. Okay, let's see what happens if we just do a console.writeLine with the variable name, because we've done that before. But with arrays, it's going to do something unexpected. Because an array holds many items, console.writeLine doesn't know which of the items you want it to print out. Now, in some languages like JavaScript and others, it'll actually print out all the elements of the array. But in C#, it just prints out the actual data type, which is an int32 array. The reason it does that is WriteLine, by default, if you pass it an object or a complex type, something that's not an int or a string or a bool, what it'll do is it will call the .toString method, which you can see is already on our numbers array. We get that for free, just like we got length for free as, a helper property. If it sees a type that it doesn't know how to handle, in this case it has multiple values, it just calls toString, and toString of an array gives the array type, which is an int array. If we actually want to show the value at a specific index, we have to type it out and tell it which index to print out. So in this case 1, it should print out the number 20, and there it is. All right, so I was going to also show you that you can replace the int array with the word var, just like we did before, and it's just as happy to work with that. I'm just going to paste an example here. It's basically the same example as above. We can also do this with var. And I've just created a new array of string that also holds two elements, 0 and 1. So if we want to load those up with some values, we can tell it names 0 is equal to Jeff and names 1 is equal to Lisa. So if I wanted to, I could type console.writeLine, turn on our interpolation, and finish off with a semicolon. I can type her name is, and put in names of 1, and her favorite number is, and I can type numbers 1. So it'll replace names 1 with the actual value that's stuck into names 1, which is Lisa, and the numbers 1 will be replaced by the value 20. And so it prints out her name is Lisa and her favorite number is 20. Yay! Well, I think we'll stop here for this lesson and split this episode up into 2. So this will be the intro to arrays, and then in the next video, I'll show you how to go in a little bit deeper and how we can use them in actual code rather than just assigning some values. So as always, make sure you practice. That's especially true with arrays because they are a little tricky when you first learn them. And I'll just keep going on and pointing out the times when I think you should put in a little bit of extra work. And other than that, you can just kind of follow along and practice at a regular pace. So let me know if you have any questions in the comments, and I'll see you online.